Well, it's actually hard and sometimes impossible, people think, to come up with a theory of the business that actually could allow you to map these input metrics and how they flow together. So usually we avoid it and we say, hey, just throw some features in there. But I took the approach that physicists theorize the universe based on how things worked in the lab. So when I was shooting those particle beams at satellite surfaces, I was trying to come up with a fundamental basis of this electron impacts this, which causes this amount of radiation, and what are the actual physical processes that get us there. We can do the same thing for our business as data scientists. We can start to model out what the flow of the business activities are, and that will get us to a better theory, if you will, theory of the case of how we can build better forecasts and better augment uncertainty. So with each piece, each step of that process, you can quantify the uncertainty at each single step of how the business flows through. And that is really, really powerful to know how and when you might be off and drive better predictions around it. So as we were saying, driver trees do require a theory. You do have to decide, we're going to build a theoretical model of the business. And sometimes that is daunting, but you can usually start somewhere. It's just insight into how your world works. It's insight into, hey, number of impressions lead to this number of clicks on this page, which lead to this number of contacts, or number of sales channels lead to this number of leads, lead to this number of conversions. You can actually model that out, and you can explain the business based on its constituent parts. And so our forecast is really only going to be as good as our theory, and our ability to understand uncertainty in each part of those value chain, in each part of that value driver tree, is going to be as good as our theory. So I'll give you a quick example of how you might do this with trying to forecast how many pool cleaners will there be in Chicago. Now, Chicago's not a great example, because why are there pools in Chicago if anyone's ever been there? This is a much better example. I think this is somewhere in the Swiss Alps. How many pool cleaners are there? In either case, you can use this for any part of your business. So let's walk through it. The pool cleaner theory from the ground up. So the way Airbnb would do it is we would create this model of how you get to pool cleaners using both a supply side and a demand side. The demand side being, people living in Chicago, people per household, share of households with a pool, pools needing cleaning, cleanings per pool per year, cleanings in a year. That's the demand side of the equation. And you would model that out and say, how many people net are going to actually need this service? Then you can model out the supply side by taking, at a high level, working weeks in a year, working hours per week, work hours per pool cleaner. That gets you to work hours per pool cleaner in a year, and so on and so forth. And you bring those two sides together in this two-sided marketplace of pool cleaners to get to a final number of pool cleaners in Chicago. So what's interesting about this, and the key with this, is that you're actually forecasting each individual metric separately, right? So when you forecast each individual metric separately, i.e. number of people living in Chicago, you know where your error is and where your uncertainty is around that specific part of your overall forecast. You know exactly where your uncertainty lies around number of pools needing cleaning, right? And so you can follow that through and say, hey, if we titrate here, that's actually what it's going to lead to, a number of pool cleanings.